Hello students, in today's session we are going to discuss a topic that is collision. First, we understand the meaning of collision, then we go for the definition. Collision means a general thought among the students that two bodies must have a physical contact. Try to understand my words. We think that when two bodies come closer and they have a physical contact, then we say there is a collision. Yes, of course, that is a collision. But for a collision, remember the two bodies need not to be in contact, need not to be in physical contact. If the two bodies have the physical interaction and where there is a redistribution of momentum, that is, exchange of momentum takes place for the short interval of time, then we say that phenomena as a collision. And remember, for a collision, always the bodies need not to come closer. Come closer in the sense they may or they may not be in the physical contact. That's why for defining the collision, the what is collision means, for definition of the collision, we don't use the word physical contact. We use the physical interaction. For the collision, the bodies may or may not be in contact. So let us see the definition. Then I'll give you the examples for that so that you will understand when the bodies come closer and without physical contact, there is a collision. How that happens, that we will see one by one. But first of all, we should see the definition of collision. So let us see the definition on the board. So what is the definition here? You can see the strong physical interaction among the bodies involving exchange of momenta. So here we are not using the word strong physical contact. Instead of using the word physical contact, we are using the word physical interaction. Why we are using this physical interaction? To remove the wrong thing that always the bodies will be in contact for collision. So that's why we are using the word interaction. How that interaction should take place? There should be some involvement of exchange of momenta. What is momenta? We have seen momentum. It is the plural form of momenta. Now, for the short interval, that is short interval of time is called a collision. But the very important point, what I have given here, you can see clearly, this is the very important point. In collision, the particles may or may not come in real physical contact. It's not necessary that the bodies must be in the physical contact. Example you can see. Let us go with this. Suppose example 1. What is this example 1? Here, what I do here is I consider a body of mass m1. It is moving with the velocity v1. Now, another body is there of mass m2, and this body is moving with velocity v2. If suppose students, if this v1 value is greater than v2, that means it should be more. Then only it can collide with this. If suppose this is less, then it will be like it will be just following the first body, that is the second body, but it is not going to have the collision. It will be just behind this body. So in order to have the collision, we should have this v1 greater than v2. Then what happens? There will be a physical contact here, and we say collision has taken place. This is m1 and this is m2. We say collision. This is a collision. In the same way, when the two bodies come in the opposite direction with the velocities, like this is an example 1, I say, this is example 2. Suppose this is one body of mass m1 and this is moving with the velocity v1, and another body is there of mass m2 and this is moving with velocity v2, then 100%, irrespective of any condition of the velocities, like except 0, then these two bodies will 100% will collide. That means they will be in the physical contact. So here we say a collision has taken place. This is m1 and this is m2. But there is a third situation where the physical contact is not necessary. That's why I have given the point in collision, the particles may or may not be in real physical contact. Let us see example 3. Suppose we have a uranium, a heavy nucleus. Instead of considering uranium, you can consider a heavy nucleus. You know, students, nucleus is positively charged. Nucleus is positively charged. Now, what happens, you know, if I take an alpha particle here, if I take one alpha particle means it is also a positively charged particle. Helium ion. Helium ion is considered as alpha particle, and alpha particle is always positively charged. So this is also a positively charged particle. Of course, you know, the nucleus is also positively charged. Now, when we throw this, or when we send this alpha particle towards the nucleus, because there is a positive charge here and here also positive charge, they will not come in a physical contact because the force of repulsion will take place. But what happens, you know, this alpha particle will move like this and it will deviate, or I can say it will scatter. This will deviate like this. That means the alpha particle momentum is changed. The momentum of the alpha particle is changed. No doubt, this alpha particle is not in the physical contact of this nucleus. Since the momentum is changed, so therefore we say the collision has taken place here. So is this any like a physical contact between this alpha particle and a nucleus? No, but still we say this is a collision. So whenever there is an exchange of momenta, you can see the second line, involving exchange of momenta, that is what you call it as a collision. I hope it is clear. So I stress on a single line that for a collision to take place, the bodies may or may not be in real physical contact. Now, students, we move to the types of collisions. We move to the types of collisions. Now, what are the types of collisions? Generally, we characterize collision into two types. The first one is elastic collision and the second one is inelastic collision. But as far as our NCERT syllabus is concerned, they have introduced the third one as the perfectly inelastic collision. Perfectly inelastic collision, but that is same as your inelastic collision, only inelastic collision, but the extreme level of inelastic collision, they are calling it as perfectly inelastic collision. So let us see one by one and what is happening, and when we say the collision is an elastic collision, when we say the collision is an inelastic collision, and when we say the collision is perfectly inelastic collision. So let us see one by one. Collision. So this collision, if you see, the first one, we have elastic collision. And this elastic collision is also called as perfectly elastic collision. Also, there is no difference between the two. Okay. Next, we go for the second one, inelastic collision. Inelastic collision. And this inelastic collision, in some books, they have mentioned it as semi-elastic collision also. So don't get confused with this. Semi-elastic collision is inelastic collision. Now the third one, what I said just now here, the third one is perfectly inelastic collision. Perfectly inelastic collision. So here, how to differentiate among these three? Let us go one by one. See the definition. If you recall the definition of collision, there should be exchange of momenta for the short interval of time. So here, in every collision, if a process or if a phenomena, if you are calling that as a collision, then 100% the momentum is conserved. 100% the momentum must conserved. Conserved means constant. Momentum before collision, or I have to say the total momentum before collision is equal to the total momentum after collision. I repeat, momentum conserved means that is what you call it as the conservation of momentum. Momentum before the collision must be equal to the momentum after collision. Let us understand this. See here in the elastic collision, first we have to say that momentum is conserved. Momentum is conserved. The first point what we need to have here. Here also we say kinetic energy is also conserved. Kinetic energy is also conserved. So that means the momentum, total momentum before the collision, that is what I say, the two bodies are there with moving with certain velocities. After collision, their velocities may or may not be equal, but momentum before the collision and momentum after the collision, that is total momentum before collision and total momentum after collision, always remains the same. In the same way, kinetic energy is also conserved in this first category, that is elastic collision. What do you mean by this kinetic energy is conserved? This kinetic energy conserved means here the total kinetic energy of the bodies which are undergoing the collision, that is before collision, the total kinetic energy before collision is exactly equal to, I can say, the total kinetic energy after collision. Hope you have understood this kinetic energy is conserved. But once you go for inelastic collision, that is semi-elastic collision, here I have to say that the first point, momentum is conserved. Momentum is conserved, no doubt in that, because if the momentum is not conserved, we don't call that process as a collision. So collision means momentum was conserved. Try to understand, collision means momentum will get conserved. Then whichever the type we consider, always momentum will be conserved. But the only difference here is with the kinetic energy. So here we say momentum is conserved, but here what happens, kinetic energy is not conserved. Kinetic energy is not conserved. That means, what do you mean by that kinetic energy is not conserved? That means the total kinetic energy before the collision and total kinetic energy after the collision will not be the same. Then if you have a doubt that what is the reason, here we are getting same and here we are not getting same, why the energy is not constant, I'll give you an example for that. What the example I can give here is, the best example, I'll take a ball. I'll take one ball, and that ball, what I do, I drop it. I'm saying, try to understand. I'm not saying that I'm throwing a ball. What I'm doing, students, I'm just dropping a ball. So what happens, the ball will go and hit the ground. That means hitting the ground, I am saying, and the appropriate word at this junction, I have to say there is a collision between the ball and the ground. Then after collision, that ball will come back and it will not reach the hand. This was the position of the hand previously from where I was living, where I left the ball. So after collision, the ball will not come to my hand, the level, I can say the same level from which it was dropped. There is a difference now. This much is the difference, I can say. This much is the difference in the height. What is the reason here? The reason here is, this was the, what I can say, the potential energy before collision that will get converted to the kinetic energy just before the collision. And during collision, what is happening, you will hear some sound. You will hear some sound. What is that sound? Sound is a form of energy. So where that energy is lost, what is the reason of getting this much difference in the height? The difference here is that difference in the height, that means difference in the energy, I can say. What is the reason? The reason here, we hear some sound when the ball collides with the ground. That means that kinetic energy before collision has converted, some part of the kinetic energy has converted to the sound energy, and some will get retained and it will reach only up to this much height. That is the reason. ये जो difference आ रहा है ना बेटा आपको, क्यों आ रहा है? क्योंकि हमको एक sound आया, वो sound, ये kinetic energy sound energy में convert हो गई. Law of conservation of energy holds good, but kinetic energy is not conserved क्योंकि ये kinetic energy sound energy में convert हो गई. Sometimes what happens, you take the steel balls and you have a collision between the two. There will be some sparks will come. Sparks will come out during collision. Spark निकलता है बेटा वहां से. तो जब collision होता है ना, तो spark निकलता है. तो ये spark मतलब, what do you mean by that spark हमको दिखा? मतलब that is can I say that is a heat. Because of that spark, that what I can say, the two spheres will get heated up. तो हीट मिलेगी हमारे को वहां पे. हीट इज ए फॉर्म ऑफ एनर्जी, राइट? तो ड्यूरिंग कोलिजन ये काइनेटिक एनर्जी, सम पार्ट ऑफ द काइनेटिक एनर्जी आई कैन से विल बी कन्वर्टेड इनटू हीट एनर्जी. एट द सेम टाइम जो स्पार्क देखे ना बेटे, that is the light, I can say, that is what we observe, that is the kind of light what we are observing during collision. That means that is also a light energy. Light energy भी हो सकती है ये. So what I was saying here is, during an inelastic collision, the total kinetic energy before collision will not be equal to the total kinetic energy after the collision. Now just I am just changing the statement. How I can change the statement? The total kinetic energy after the collision is less than the total kinetic energy before the collision. थोड़ी सी कम हो जाती है. अभी मैं आपको बताया था डिफरेंस इन द हाइट, कम हाइट पे आया. तो ये हाइट क्यों आया बेटा? What is the reason for this difference? The reason for this difference is during collision, the kinetic energy, a part of kinetic energy will get converted into the sound energy. It may get converted into light energy. It may get converted into heat energy. So that conversion is taking place during the collision. That's why we say the kinetic energy is not constant. The kinetic energy is not conserved under inelastic collision. Now let us go for the third one. That is what we have a separate place for the third one, that is perfectly inelastic collision. So here, if you see the first one, here momentum is conserved. Kinetic energy is not conserved. Momentum is conserved, but kinetic energy is not conserved. That means kinetic energy, it may take any form. That means a part of the kinetic energy, a fraction of the kinetic energy will get converted into heat energy, light energy, sound energy. Then you may get 100% a question in your mind. Then when these points are same as this one, then what is the reason of differentiating that, or what is the importance of giving a separate place for that perfectly inelastic collision? Remember one thing. In inelastic collision, what happens, the bodies after collision, they will move with their independent velocities. इसमें बेटा क्या होता है, try to understand. collision के बाद the two bodies will get separated और वो दोनों अपनी अपनी velocity से आगे बढ़ेंगे after collision. But in this, यहाँ पे this is a very important point. During collision, two bodies get attached, and after collision, the two bodies move with same velocity. That is the difference. Additional point I am giving. What is happening here is, when the two bodies are coming and colliding with this, in this situation, after the collision, the two bodies will get separated and they will move independently with different velocities. But here, when the two bodies are in collision, their collision has taken place, दोनों क्या होगा बेटे, इस एक दूसरे से कांटेक्ट में आ जाएंगे, और जो है दोनों आफ्टर कोलिजन दोनों बॉडीज एक साथ मूव होंगे. ये अब सेपरेट नहीं होंगे, दोनों एक साथ मूव होंगे, तो उसको हम बोलते हैं परफेक्टली इनइलास्टिक कोलिजन. लाइक कभी भी आप देखिए एक्सीडेंट में, एक ट्रक और एक कार में जब एक्सीडेंट होता है बेटा, तो ट्रक और कार आकर एक दूसरे से टकराएंगे. विल यू एक्सपेक्ट दैट एक दूसरे से टकराएंगे और ये टकराने के बाद चलो हट गए और हट के अपनी वेलोसिटी से चले गए और अपना रास्ता देख लिए? हैव यू सीन द सिचुएशन लाइक दैट? नो. क्या होता है बेटे, जब कोलिजन होता है और जिसकी काइनेटिक एनर्जी ज्यादा होती है, तो वो क्या करेगा, दूसरी बॉडी को ढकलते हुए आगे लेके चले जाएंगे. सो दिस इज द सिचुएशन व्हाट वी कैन एक्सपेक्ट. दोनों भी कांस्टेंट और कॉमन वेलोसिटी से मूव होते हैं, यहां पे इंडिपेंडेंट वेलोसिटी से मूव होते हैं. सो व्हाट वी हैव सीन, The types of collision, the first one elastic, the second one is inelastic, and the third one is perfectly inelastic collision. I hope you have understood all the three types of collisions.